Hello and welcome to the LLM Innovators Showcase. My name is Caroline Frasca, and I work on developer relations at Snowflake for Streamlit's open source Python library. The LLM Hackathon was an app-building contest hosted by Streamlit in September of this year. Hundreds of users built amazing Streamlit apps powered by Assembly AI, Clarify, LangChain, Llama Index, and Weaviate. Today, you'll meet 5 of the hackathon winners and watch them demo their winning apps.
Hi everyone, I'm Enric Domingo. I'm from Barcelona. I work at Ernie as a machine learning and software engineer. I also create some content at YouTube. You can find me there, Enric Domingo. I create some videos, for example, about Streamlit. And I have created this application, the LLMs Arena, to participate in the Streamlit Hackathon. So I've been using the LangChain library. So that was the category that I was participating in. The LLMs Arena is basically a game where the players are the agents that are controlled by OpenAI models in this case. Here we can select which model we want for the player 1. Let's select GPT 3.5 for the player 1. And for the player 2, we can select the same model or another one. Let's put GPT 4 in this case, for example. A little bit more expensive, but also a little bit better in general. Here we have to define the prompt that every agent will be receiving at every turn, and it's much longer. So we define here the instructions, how we want to tell the model how to behave to play this game. And when we define both models and both prompts, we can start to play. It's not fast because at every turn, both models have to do the long prompt and receive also a quite long response from the model. So it takes on average around 2 to 5 seconds for every agent to play. Now we can see here the first turn. So we can see here the reasoning and the final decision for this agent and this other one. And something pretty incredible is that they are quite worse than I was expecting. So I was expecting them to play quite good because it's a pretty simple game that everybody knows. So for sure, GPT knows in advance about the snake game, but it's playing quite bad. We can see here, for example, the blue snake now doing strange things, it's almost about to kill himself against the wall. So yeah, that's something pretty incredible that I found. Yeah, here, for example, the blue snake already died, hitting with himself. And here we can see something else that I implemented, that is some metrics of the game. So I'm recording here for every turn the number of tokens that every agent is using, the cost of those tokens. So GPT-4 here, the blue line, is quite more expensive than GPT 3.5, for example. And here we can see the response time. I've been implementing all of this with LangChain callbacks, with LangChain models, prompts. So LangChain has been quite useful to develop all of these features. And here are some summary statistics also. So this has been one example, a pretty short one. Sometimes they end up at 15 or 20 turns, but at this case, it's been pretty worse. So let's see the architecture of the application. I made here this slide. So yeah, as I explained, the logic starts by defining the model with LangChain, then the prompt templates as well with the LangChain templates to define those with the placeholders where we want to pass at every turn the word state with these 3 ways that I explained. And when we start, there is the game engine that defines the logic of the game, and also it's in charge to display every turn using OpenCV. So at every turn, the game engine passes the template to every model, and that's the API call to OpenAI. And every model receives the response with the reasoning. It's optional, and on the arrow. And the game engine takes back the response of this model, and it looks for the arrow, for the emoji arrow, and it applies this to every agent. So it applies this change at every turn. Okay, the agent 1, the snake 1 wants to move down, and the snake 2 wants to move left. So it applies this logic. It displays the next turn, the next frame. It checks for if any snake has lost or has eaten some food, and it goes until some dies or some wins. And here we see also the game stats that I said before. So as I mentioned, this is the tech stack, the libraries that I've been using for this project. Streamlit, of course, LangChain, the OpenAI API that it's behind this. So using LangChain allows us now to, for example, increment this application, putting here other models. For example, we could deploy Llama somewhere or some other paid service for some other model. And with the LangChain interface, it will be quite much easier to implement now other models. But yeah, for this demo, I only implemented OpenAI so far, and also OpenCV to display the game board at every turn. So it's basically static images that are built in the backend and passed to the Streamlit frontend at every turn. So yeah, that's it from me. Thank you very much for joining.
Welcome everyone to Search Wikipedia, my app. My name is Markus Schiese. I'm a longtime software engineer, and I wrote this app to improve searching Wikipedia. You can type in your own natural language query and get then related articles to your natural language query. As you can see, there are a couple of suggestions what you can already pick, like time travel movies with a twist. But this time we will use our own query, which I'm going to type now. Travel destinations known for their mountains. Maybe we want to go on a mountain trip. So we're looking now for similar articles. We already find a couple. Here we see the article from Bosnia and Herzegovina. I can open that and the Wikipedia page is opened. And then I go back and I see that we have a summary here generated by the large language model of the article. So it's a little bit easier to digest the information. So now I could ask another question, a second question. I'm not going to do that. Instead, I will explain you the architecture. So when the user is typing in a question, we first calculate the embedding of that question. And then we are using this embedding to run a similarity search on the VVA database. That way we are finding article chunks which are similar to the question asked. So the result set is the chunks of article. These chunks we are passing to the aggregation function, which, among other things, takes care that we only get one unique article. Because the chunks of articles, we might have one article multiple times, but we only want an article once. So the result then is that we have a set of articles, which we are displaying. In our case, which are just demoed, they were 3 articles. So we display the 3 articles, send then the articles to the large language model to summarize them, and then we are displaying the summaries. So much about the architecture. Now the question is, what are the next steps? How could we improve this little app? So one thing is we could add multiple languages, add support for multiple languages, because the VVA database already stores articles for different languages. So it's easy to add support for multiple languages. Another more complicated feature is to navigate over related articles. So we see an article, then we could imagine that I click on an article and we use the similarity search to find similar articles. That way we could navigate the whole knowledge database that we have by this vector database. Thanks to Streamlit, Cohere, and Vivid for providing us these great technologies. And I wish you all a great day.
Hey everyone, my name is Vishwas Gowda. I'm an ML engineer at clearfeed.ai. And today I'm showcasing my LLM app called FinSight, Financial Insight at Your Fingertip. So FinSight is basically a cutting-edge AI assistant for portfolio managers, investors, and other finance professionals and enthusiasts. It basically streamlines the process of gaining crucial insights and summaries from company annual reports and other financial data. So basically, there are two parts to FinSight, which is Finance Metric Review and Annual Report Analyzer. So today I'll be going through the Annual Report Analyzer feature. So yeah, this is it. Once you enter your OpenAI API key, you need to go to the company annual report that you want to generate insights from. So today I'm doing Apple. So this is the Apple 2022 financial report. So it will take a few moments to process the document. These documents, usually they're publicly available on the SEC website and also the investor relations website. And they typically range from anywhere between 50 pages to 80 pages of PDF. Yeah, right now, as you can see, the document process has been done. So now we get to select the insights. So let's just select a few and put it to generate. Yeah, so let's just press on Analyze Report. So now this will take a couple of moments. So let me just, while this is happening, let me just go tell you the problem that actually a lot of professionals in finance are facing. So basically, these annual reports, as I said, they are very long and very tedious to read. As I said, around 50 to 200 pages. And when you multiply it by the number of years, let's say 5 for the past 5 years, and multiply it by many number of companies, so it's a big, very tedious and boring task to say the least. So we thought, why not generate a few insights, harness the power of LLMs and generate a few insights from these, and actually reduce the time and help them make more financial decisions. So yeah, right now we have generated a few insights. So the first section we have is called Fiscal Year Highlights. So basically, we're just highlighting all the things that has happened over the past few years for Apple. So when it comes to performance highlights, as we've chosen it here, as you can see, the total net sales has increased by 28 billion, so or 8%. The net sales was primarily driven by the sale of iPhone services and Mac, and also repurchased 90.2 billion of its common stock, and so on and so forth. And the strategic outlook and future direction section. So in the report, they usually highlight also the few strategic initiatives the company has taken over the past year. So as you can see, it says expanded market opportunities in smartphone, personal computer, tablet, and wearable accessory sector, as well as services. Relies on outsourcing partners to component manufacturing and logistical services, primarily located in Asia. So as you can see, Apple has taken quite a few initiatives over the past few years. Now let's go to risk management. So this is another very important section when it comes to actually getting knowledge about a company's financial health, what kind of risks they've taken, industrial accident at supplier and contract manufacturers, public health issues such as pandemics, global market competition, price pressure from gross margins, and supply pricing risk for components, industry-wide shortages, and public pricing fluctuations, right? So there's innovation and R&D as well. So yeah, if you choose any of these insights, it will generate for you a couple of minutes max for the entire generation of the insights. So yeah, basically I divided them into 4 of these sections after talking to a lot of financial analysts and investors. So after talking to them, these are the most used insights, I would say. So yeah, I think this does a very good job of generating insights and actually reducing a lot of time for finance professionals. So yeah, that's it from my side. Thank you, everyone, and have a great day.
Hi, I'm Sully. I'm a software engineer with about 15 years of experience. My hackathon project was called the Persona Simulator. This project was really more of an experiment and work with large language models in an attempt to really build any kind of finished product. I've spent a fair amount of time working with large language models, exploring ways to make them do interesting things in a reliable and consistent way. And I'm thoroughly convinced of their general purpose reasoning ability, particularly when you're talking about GPT-4. But there are still many things missing before you could consider something like an AGI, an actual artificial general intelligence. There's no memory. They don't have any internal monologue. These models have no freedom to choose their own tasks. So this app was an attempt to, in a very small way, provide some of those capabilities. The actual idea is basically, what if I set up a system where I defined a number of personalities and gave them access to a set of tools and actions they could perform for expressive output and internal reflection, and build a system that would allow them to, these personas to define tasks for themselves and use those tools to perform those tasks. And it was kind of the questions I was hoping to answer was, A, could I get them to do anything and actually perform? Would they have interesting thoughts or produce equal content? Would they consider their previous tasks and build upon them? And then, lastly, would there be any just other cool emergent behavior? With my previous experiment with LLMs, that's always been the most interesting part is, what happens that I didn't anticipate? So here on the main page of my app, I've linked to like the ChatGPT session where I work to define some of these personas. So you can kind of see what that looks like and what that process was to get them into a form that I could use easily in an app. And, I talk again more about my motivation here and share one of the videos that got me interested in working with LLMs in general and thinking about artificial general intelligence. And, I linked to some of my previous LLM experiments here if you're interested in checking those out. The tools that I came up with for the AI to utilize are also listed up here. So there's just a handful, and you can see they can do things like read from their blog or from their journal. They can create art. They can write in their journal, which is the main mechanism of reflection and thinking about things. They're instructed whenever they need to think about something to write in their journal about it. They can post on social media. They can write a blog post, and they can query for information, which is the way that it can, ask questions and get answers. And again, it's instructed that it can only write blogs and things about information it's queried for. And then if we scroll down here, we can see kind of where the persona selection would begin. So if you were, while the hackathon was in progress, it's in read-only mode now, so you can't trigger a new thought. But this is where these personas, you could select and start a thought for a persona. And so you can see here that description and interest that came up that were defined by ChatGPT. I also had ChatGPT generate like a description, a physical description of a picture of the person, and then sent that off to Stable Diffusion. And so that's where these images come from. So here's the personas. We've got Dr. Eleanor Reed, who is a biophysicist blogger. There's Luna Martinez, who is an abstract artist. Caleb Fletcher, who is a writer. He does a historical fantasy serial blog. Alex Harper, urban photographer. And Mila Bennett, who is a children's author. These were the 5 original that I started the app with. During the hackathon, I was really enjoying the content that was being created. And so I added 2 additional personalities to kind of get some focused content creation and see how it looked. So Layla is a nature artist, and Lucas Darkthorn does like a game master post for Dungeons and Dragons. He posts content about gaming. And so if the app was not in read-only mode, here's where you would trigger the thought, and you could provide a nudge, which is just a short description of maybe the task you'd like the personality to perform. And this ended up being the most interesting thing, was seeing how these personalities would respond to these nudges. So we can't trigger a new thought right now, but we can load up one that isn't complete to see what that would have looked like. Let me grab one here, and we will load. So if we had just triggered a thought, the main page would switch to this view now. So what would have happened there is it would have sent out a prompt to GPT-4 and asked it to, given it information on the personality, some things that have been recently done by this persona, and the tools that are available, and asked it to decide upon a new task. And so in this case, I will investigate the role and impact of nanotechnology in the field of biophysics, and then, expand from there. And you can, see the rationale for why she decided to perform this task. And, it's interesting because she is considering her recent blog posts she's posted about quantum entanglement and quantum computing, the ethical implications of CRISPR. And so she decided to continue in that trend and post about nanotechnology. And then in addition to the rationale, her plan for how to accomplish this using the tools that I've given. And then here you would, you'd be able to walk step by step through that plan, let her perform each step in sequence. And then the current thought context, which is blank right now because we're here at the beginning of a thought, but this is the mechanism for passing data between steps of the plan. So, the query for info step would result in this context being updated. And that's the only information that's going to continue on as we move through the plan here. That's my app. It was really fun to build, and I really enjoyed having access to these resources to experiment with. And Streamlit is a great tool for building these apps.
Hi, I'm Kanji Ho. I'm located in San Francisco. I'm senior machine learning engineer at Taylor. So I'm gonna demo the NewsGPT, the LLM Hackathon app. So the first scene here, you can see that the sidebar it tells us some information about how NewsGPT save your time. So it's which means that the total save time here is indicates that how many times that NewsGPT help you to save, and the total read time is only like 1 minute, and the total save time is like 29 minutes. So basically, if you see the articles here, this is the feed for your. It's kind of like a personalized feeds for every single user. So after you have some activities or you have any preference on any articles, then the NewsGPT will collect those activities and then generate the personalized feed for you. So that's say if we can also like tag on Cisco and just search about some articles related to San Francisco, then we started to query our vector database, and you can see that there's like an epic road closure, blah, blah, blah. And if you're interested in this kind of articles, you can just like chat with articles. So the chat with articles would lead you to a chat session. So it needs a little bit of time to do this. And you can see that it would start to stream and give you like a automatic prompt first that to ask for the summary. And then it will come up with a summary, and then we also have the predefined prompt here. So you can ask the 5W1 edge or similar viewpoints or discrepancy viewpoints. So let's say if you want to see the 5W1 edge, and it would help you to ask, and also streaming, just like how it works in ChatGPT, as it tells you everything that you need to know about the articles here. And also, I also mentioned about that the preference of the article. So if you think that this article is pretty good, then you just click the I like this content. And the reference articles here will be the related articles that is surrounding this topic from different news sources. So that's how we calculate the total save time. So if you want to read the like 4 or 5 articles, it's going to take a lot of time for you. But for the NewsGPT, it's happy to summarize then like 5 articles together, so that within reading the simple paragraph, like a few words, then you can directly know the entire contents of the 5 articles. So that's the main thoughts of it. So the diagram here for the NewsGPT, we have 2 things here. The first is the data pipeline. The second is the Streamlit part. So the data pipeline help us to ingest the news articles every day. So it started with like a thing scrapping of the Google News, and then we send it to the topics, the Kafka, and then do some processing through the batch streaming with Spark. So we have the name entity recognition, and also generate the embeddings with the OpenAI APIs, and then everything is prepared. Then we send the payload and the vectors to the Quadrant Vector Database. Okay, so for the Streamlit part, so that as I said, that when user get into NewsGPT, you can choose to use the guest login. But just to mention that the guest login will disable the personalized part, so you won't get your personal feeds for your preference or your from your past activities. So if you log in, then we'll call the Firebase authentication for to see if you are already signed up, and also grab the preference and activities from our database. And after that, we'll send your activities to the quadrant vector database and use the recommendation API that is hosted on at AWS Lambda to get the recommendation. So we'll get a list of recommend articles and displayed on the Streamlit. So as you see that let's say that this is the recommend articles, the news articles A, news articles B and C, and . So when clicking on each of the articles that you're interested in, let's say I'm interested in news article A, then it also we also call an API that is hosted on AWS Lambda, and then search the related articles from different sources that is surrounding the same topic through the quadrant vector database. And so we get the A related articles. So after we grab all these articles together, and we send into the Llama index and perform the reg. So you can see that from our demo, you can see that we have our first automatic prompt for asking the summary, and it get us the response of the summaries of all these related articles. And then user can also ask the query inputs, the query questions for that. Say though, if it's about the word, and we can ask that if there's any injuries, what's the numbers of the injuries, and we can also talk to the chatbots, talk to the articles for more deeper information. So if you're interested in NewsGPT, you can also take a look at the notice I mentioned, the production-wise app. Yeah, so thank you, everyone.
Thank you for joining us at the LLM Innovators Showcase. Be sure to scan the QR code to learn more about building generative AI apps with Streamlit.